Hey everybody, Mr. Fortin here. I got classroom exercises number 8 from the section 1-1 homework. Now, I definitely got questions about this in the second block today when we were reviewing. I think the answer was incorrect on the board, but we tried to talk about why it was incorrect in class. I know that third block you're doing this homework and it's due tomorrow, so maybe you're watching this video. That'd be great. Are X, O, and Y, are they coplanar? True or false. Now, sort of what it's getting at here is just to realize space in the world around us. Planes are everywhere in space, right? They're here. Infinitely thin surface, called the infinite surface. Here, here, everywhere. Everywhere you can have this two-dimensional flat surface and orientated anyhow, thereby which a plane exists. So the problem with books and problem with diagrams here and here is here. I tried to redo the diagram in a tool. We'll look at this in a second. Is that a diagram really is just going to feature one of those planes. So right here, we're looking at plane M, the orange plane here in the diagram. We're not looking at a plane that would be at angled like this, at that orientation in space, this orientation in space, this orientation of space. So you could have a plane M right here, and there are plenty of other planes cutting into that plane because infinite surfaces you can define. There's two-dimensional figures like all the ways in space, right? Infinitely many ways we can have planes running. So we're just featuring one. We have here plane M. So I think the issue with second block, okay, at least getting this one incorrect, misconception, if you will, the first time, is that R, X, O, and Y are not all in plane M, okay? R, O, X, and Y, right? Why? Well, because X and Y aren't in plane M. So if this is plane M right here, X is above plane M based on our orientation. If this is plane M, X is above it, okay? And Y is below that plane. They're not contained by plane M. They're not in plane M. So they're not all in this plane that's featured, but are they in any plane? Okay, remember means together, planar means of a plane, okay? And planes are everywhere, right? We just can't actually, it gets messy, and I'll show you in a second. It gets messy really to draw more than one plane on a sheet of paper. So then the question is, can we get R, X, O, and Y to fit that definition together in the same plane, coplanar? And the answer is yes. This one is true because there exists a plane that would contain all four of those points. We'll look at this in a second. I'm going to show you that plane because if I have a point R here and a point S here and a point X here and a point Y here, there's a plane and it kind of looks like this. Okay, this plane here would go through R, would go through S, and then I'd have the actual line. I could draw the line. I drew it in class today. The line XY would be fully contained in this plane that goes through the paper. Okay, confusing? Maybe. Let's look at this diagram here. I got point R, I got point S. This is plane M. Again, X and Y aren't in plane M, but I'm going to show you the plane in just 1 second. I got to move it here. There's the plane. There we go. This plane here that I just added to this, yeah, it's like kind of a vertical plane, and it contains all four of the points here. Look at that. Green one has got R, it's got Y down below, it's got S, it's got X, right? So the planes are everywhere, okay? They have tilts, right? If I this is the plane, I tilt it, that's a slightly different plane, right? So there are a bunch of different planes that we have here, okay? And there we have it, okay? So that's maybe what you had trouble visualizing was there was a plane there, right? There's a plane in space that would contain all four of those points, okay? Some of the other ones with all four of those points, there isn't a plane that contains them all, okay? That's if I have a point here, a point here, a point here, and like a point way over here in some random location, okay? But here, I got myself a plane. Hopefully this video helps you find it. Those 4 points are indeed coplanar, even though we don't see that plane in the actual problem. Thanks for watching. I will see you guys soon. Bye.